want to give Tim an extra round of applause for being patient with all that noise. Thank you. But the talk was so fascinating that we felt it through. Our next speaker is Nigam Shah.
Okay, so it's going to be tough to top that performance, but let's see. Maybe a video will play. So I haven't changed my title, and I'm going to talk about using ontologies for reasoning in a virtual cell. And when Phil invited me here, I took this font, and I wanted to be clear why would I go to this meeting if I do go. And there are two goals. One is that if you're going to build a 3D virtual cell, you're going to need ontologies. And I'm part of a center called the National Center for Biomedical Ontology that this community, if formed, could use. So reason one. And then I have a few things to say on reasoning about cellular processes, which I hope a 3D virtual cell would enable. And so two reasons and basically a summary of my presentation. And let's try to get through those without running out of time. So NCBO, we do three key things. We create and maintain a library of biomedical ontologies. We build tools and web services to enable the use of these ontologies and their derivatives. The work that Tim just presented, Domino, uses one of our web services for annotation. There's lots of other groups that use these web services. And then the third thing we do is collaborate with scientific communities that develop and use ontologies, and try to make sure that they are indexable by at least ontology search engines. So, in order to give you a one-slide summary of this center, I want you to remember the two black boxes that show up on this slide. So the first one is rest.bioontology.org. If you are a programmer, that's the server address you want to remember. And for people who are not, I'll show one at the end. And then there's 5 buckets of things you can do if you access this resource. You can do things with ontologies and views, which are subsets of ontologies. And you can download them, traverse them, search, comment, blah, blah, blah. This is primarily of interest to people whose love in life is to build new ontologies. So if for the 3D virtual cell, you're going to build a new ontology, that's the part of NCBO you want to check out. Then there's mapping services, which basically allow you to create, download, and upload mappings, which are associations that tell you melanoma in the MCI thesaurus is the same thing as melanoma in SNOMED CT, or mitochondria in the cellular component ontology is mitochondria somewhere else. Then if you're building tools or websites, we have widgets for TreeView, autocomplete, and GraphView. I'm going to show one. If you want to limit input to a controlled vocabulary, we can give you 3-4 lines of JavaScript. You start typing, you'll see suggestions that are terminology of your choice. And once you hit select, the underlying code, the ID for that term will get associated with your data. There's an annotation service where if you send us a paragraph of text, if there are ontology terms mentioned in it, we will send those back to you. That's all it does. And then finally, if you have a resource which archives papers, experiments, methods, what have you, we want to crawl it and index it so that if you search for a term like a melanoma, we want to fetch data annotated with that particular term. And this is actually a collaboration with people here who are helping us expand this index significantly. People in Marian Martone's group. Okay, and it's just some big numbers over there. If you are not a software developer, the server you want to remember is bioportal.bioontology.org that allows you to do things in a UI. Okay, so that's the part about NCBO and what we could give you. So now getting back to the So if you think about a cell and pathways and models, and we've sort of talked about models a little bit this morning, I'm not going to read out this definition, but basically a model, I think of it as a static description that allows you to study the characteristics. A pathway, on the other hand, I have no clue what it is. It's a concept that's that's often used, but almost never clearly defined. This is the best I could come up with. I mean, it's a set or series of interactions, often forming a network which biologists have found useful to group together for organizational, historic, biophysical, or other reasons. I mean, it is literally a grab bag of things. And here's the problem. Pathways are assumed to be models. And the assumption is made without actually declaring the modeling formalism in which that model would be valid. And then hence most pathways end up being just lists of heterogeneous sets of steps. Sometimes jumping abstraction levels, jumping cellular components, going from the outside of the cell to the nucleus without explaining how, and all sorts of funny things. So the claims are that a 3D virtual cell that does not support pathways will have limited utility. I strongly believe that. Biologists love pathways. But pathways are useful only if they serve as a model of a biological process. So now you have these two mutually opposing views. So as a community, whatever needs to be done to ensure that a pathway that you would choose to support valid model of at least one formalism, that should be required of pathway authors. If you can follow this one thing, I think that will advance the field of analyzing data in multiple ways forward in many disciplines. Okay, so if you were to do this, if you were to subscribe to these claims and hence choose to do whatever needs to be done to ensure that a pathway is a valid model, I have three suggestions. One, use explicitly typed links. So don't draw things where the lines have no meaning. It's worthwhile to sit down and argue and move beyond hairballs to introduce explicit meaning of the links that you choose to in your representation. Most people know what this is, or if you're a Yahoo fan, what this is. We need something like that in representing pathways and models. So going from the cell cycle in the biomodeling world all the way to the cell cycle in the Go biological process. And yes, these use the same string of characters, cell cycle, but they're widely differing things, and we need a way to bridge that. And third, truthful to cellular geography. The cellular component ontology, which is a portion of Go, has maps to a particular three-dimensional location in a cell. And today, if you were to take pathways, and this is an old graphic from one of the old issues in Nature, where they drew the analogy of pathways with the Manhattan rail system. If you were to overlay this on cells, today a lot of these pathways would be logically inconsistent, jumping cellular compartments without telling you how, and doing sort of nonsensical things. Now, if you were to follow all of these three suggestions, then the reward is that you can have formal representations of models, or biological pathways, So this is just a cartoon representation of the galactose metabolism in yeast and how the yeast switches from glucose to galactose metabolism. And these pathways will then have a formal representation, which will have steps that you could link to argumentation structures that support or contradict that particular individual step. And if you're able to do that, this is a real screenshot, you can then submit a model for evaluation and get a breakdown of the steps that were said, how much support or contradiction, rather, I emphasize prioritize contradiction over support, look through the data to see what steps in your model are not possible, rather than try to support those steps. And then the evidence that my evaluator says this step is wrong because the annotation of this particular protein puts it in the cytoplasm, and well, common sense, you need to be in the nucleus if you're going to induce transcription of something. So that's the reward. And with that, I'll end.